Just some things to think about whenever you're trying to find the slope of a line and you're working directly with a graph. So when you're counting the rise and the run and you're counting grid squares, if you're ever counting in an upwards direction or in a rightwards direction, that's always moving positively. Whereas if you're counting in a downwards or a leftwards direction, you're counting negative units. So seeing how that kind of plays out in an example right here. So if I were to find the slope of this line in the graph right here, and let's say I suppose I started counting at this particular point on the line right there, and I was going to move to, let's say, this other point on the line. So if I was starting there, you'll notice that I'm moving downwards, which would be a negative direction. So I'd have to denote that as negative units of rise, and it ends up being -6. And then when I move in this direction right there, that's rightwards, which is a positive direction. So I'd leave that as at a +4. And so the slope would be the rise over the run, which would be -3/2 that we get for our slope. Now you could also, if you had wanted, start at, let's say, this point down here, and you wanted to move to, let's say, that point up there. So then if I were to move this direction in the rise, note that I'm going upwards, which would be positive, so it ends up being a total of 9 units there. And then if I move in this direction, that's leftwards, which is a negative direction, so you'd have negative, and it ends up being 6 units. So your slope would be the rise, which is +9, and the run, which is -6. But then again, that does end up simplifying down to the same answer of -3/2. So you always get the same slope, of course, no matter how you find it. So being able to find the slope of a line from a graph, just in some examples right here. So if we start with line DC is going to go from this point to this point. So if you're just working off of a graph, you can just count unit squares. And so you'd want to find the rise, which right there would be 1. And then if you count the number of units of run across there, ends up being 6. So you end up getting a 1/6 slope, which we know ends up being a positive type of slope because it is increasing as you go from the left to the right there. And then if we move to line AC, A is right here and C is right here, so you can see it's trending downward, so we should expect a negative answer for this because it'll be a negative slope. So if you count 1, 2, 3, 4, 5, that's 5 units of rise, which we'll say is negative since I counted downwards, and then I'm moving right, which would be positive. That ends up being 6 units, so you end up getting a slope there to be -5/6 for line AC. Then for line AB, A is right here and B is right here. So anytime the line is horizontal, like you should just know it's going to be a 0 slope. And you could tell that because the rise is going to be nothing, right? And so you get 0 over, and then in that case it ends up being 5, but that's just going to reduce down to 0. And then for the last line between points A and D there, you've got A here and D here. So anytime the line is just vertical, you should know that that slope is undefined because the rise right there is going to end up being like 6 units, but then in terms of run, you're going to have nothing because it's not really moving left or right at all, so you end up with 6 over 0, but then anything divided by 0 is undefined. So as you're finding the slope of a line from graphs like these, so if I were to find, let's say a couple ordered pairs on here, so like right there, there's a couple ordered pairs. So it appears that like you're just counting down 1 grid square and then 2. So you might think, okay, well that's got to be a -1/2 slope because it's a negative slope. But it turns out that it isn't. It's really important that you take a look at the way things are labeled because right there you have 24 and 21. So actually we didn't go down 1 unit, we actually went down 3 units. And then if we look at the x coordinates, we actually went between 4 and 8 right there. So we actually didn't travel a distance of 2. We actually traveled a distance of 4. So the correct answer for the slope would actually be it's a -3/4 slope. So you can't just really count grid squares. You have to pay attention to the fact that the labels might be skipping by certain numbers and that sort of thing. Now in this particular scenario, you'll see that each like grid square is counting by 3s in the x-axis as well as in the y-axis. So if you're finding the slope of this, it turns out that like right here, of course you are going down actually 6, and then you're actually going over 12. So you get -6 over 12, which would mean this is a -1/2 slope. But if the x's are counting the same amount of numbers as the y's, then it does actually kind of work out that if you just said this was -2 and then this was 4, that actually you will get the correct answer. But that's only if the the counting of the x's and the y's are going by the same intervals. Otherwise, if the x's and y's are counting differently, then you're just going to have to make sure that you actually figure out the exact distances the x's and y's are changing.